Welcome to the Crystal Math Lab. I'm Mrs. Koch, the inventor of Crystal Math. This is my assistant Pi.
What's up?
And our mission is to get you hooked on Crystal Math. Today, we're going to talk about lines. Want to do some lines? Let's talk about lines.
What lines?
That line.
That line?
No, that line.
That line.
No, that one over there.
Which one are you talking about?
You know, that's a really good question, Pi, and that's exactly what we're going to learn today. How to name a line. We use something called a linear equation. So what do you say? You ready to do some lines?
Yeah.
Then let's do some lines. Alright, so the first thing we need to understand, there are 3 different ways to name a line. I mean 3 different ways to name the exact same line. We could use standard form, slope-intercept form, or point-slope form. Think of it like you have 3 different names and you rearrange them. Maybe you have the name Robert William Smith, and you decide one day you want to be Robert William Smith, the next day you're going to be Bobby Bill Smith, and then you're going to be Bobby Willie Smith. Doesn't really matter. The bottom line is you're still Robert William Smith. Think about a baby that was just born. If the parents haven't picked out a name yet, it's just called baby boy or baby girl. It's kind of the same way with the forms of linear equations. Standard form, before it gets its actual name, is ax plus by equals c. Slope-intercept form, y equals mx plus b. And point-slope form is y minus y sub 1 equals m times x minus x sub 1. We have 2 things going on here, something called arbitrary constants and something called variables. Notice, every form has an x and a y. The x and the y are what we call our variables because if you remember the coordinate plane, every point is an x and a y. Since there are infinite points on the coordinate plane, and actually there are infinite points on a line, that's what makes it a line, there are infinite possibilities of what we can put in for x and y. Hence, x and y are our variables because they can vary in what their values would be. Sure.
Aha!
Okay, so what is a variable? A variable is a letter used to represent an unknown number. It's a variable because its value can vary. Now when it comes to an arbitrary constant, it's a letter used as a placeholder for an unknown number. Arbitrary because you're not quite sure what it is, and constant implies that a number will not change once we know what the number is. In our forms of a linear equation, a, b, and c are the arbitrary constants of standard form. M and little b are the arbitrary constants of slope-intercept form. And y sub 1, m, and x sub 1 are our arbitrary constants of point-slope form. Once we discover what these numbers should be, we will have the name of our line. The only way you're ever really going to understand all this is if we walk through the different steps of actually finding the name of a line. So let's start with, what's the name of the line that goes through the points -2, 3, and 6, -1? Well, the first thing you need to recognize is you're given 2 points. And there's only one thing you can do when you have the coordinates of 2 points. That is find slope. So what is slope? Well, the definition says that slope is a constant rate of change. But wait a second. Oh, that is so confusing. Didn't we just say that constant meant it never changes? But rate of change says it changes. So how can it be a constant and a rate of change at the same time? Check it out. The slope tells you how many units you travel from one point to another point on the coordinate plane. Since it's a straight line, you're always going up and then over the same constant number of units. Make sense? I hope so.
Yeah.
There are different ways to describe slope. Some say it's rise over run, while others say it's m, change in y's over change in x's, and even the opposite of a over b. These are all different ways to describe the same thing. It's kind of which one do you like best, or which one works best for the situation or the form of the linear equation you are using.
Slope.
Since our topic's about linear equations, why don't we get back to our example? We want to know the name of the line that goes through the points -2, 3, and 6, -1. Remember, the only thing we can do at this point is find slope. So we're going to use the change in y's over the change in x's. Remember, subtracting a negative is add the opposite, so we end up with 4 over -8, which reduces to -1/2. So our slope is -1/2. Now that we have the slope, -1 over 2, we'd like to find the equation of the line that goes through the points -2, 3, and 6, -1. Now remember, when we say equation of the line, we're talking about the name of the line. The easiest form to use is point-slope form. For point-slope form, all you need is the slope and any point that's on the line. Interesting, in Algebra 1, we tend to skip over point-slope. We're more interested in slope-intercept, it seems. But yet when you get to calculus, it's really important that you know the point-slope form, because when you need to find the slope of a tangent line, or the equation of a tangent line to a curve at a given point, it's easiest to just use point-slope form. Anyways, all we have to do is plug in our 3, which is our y, so we get y minus 3 equals our slope, -1/2, x minus, and then our -2. And yes, we could just make that x plus 2. Or, if we choose to use the other point, we put in the -1 for our y sub 1 equals the slope of -1/2 times x minus our x-coordinate 6. And that's how easy it is to write the equation of the line in slope-intercept form.
You mean point-slope form, right?
Right you are. My mistake. My bad.
Okay.
Slope-intercept form and standard form aren't quite as easy as point-slope form, but they are still easy. Let's see. Slope-intercept form is y equals mx plus b, and standard form is ax plus by equals c. They both have an x and a y. Only slope-intercept form has y isolated on one side. What if we took standard form and tried to isolate the y on one side? Wonder what would happen. Well, let's have some fun. Let's check it out and see.
Yeah, let's do it!
The first step in isolating y would be to subtract ax from both sides. This will now give us by equals -ax plus c. To isolate y altogether, we need to divide each and every term by b. This ends up giving us y equals the opposite of a over bx plus c over b. We got some neat things going on here. Check this out. Whoa, this is so cool. If I take my y equals the opposite of a over bx plus c over b, and I write the slope-intercept form right underneath, y equals mx plus b, I start to notice that, look at that. The opposite of a over b is exactly the same as m, which would mean that slope is not only m, it's the opposite of a over b. And c over b is exactly the same as little b, which would mean my y-intercept, represented by little b, could also be c over b. Knowing this is going to really help us understand how to go from slope-intercept to standard form and standard form back to slope-intercept real fast to where you'll get to where you can even do it in your head.
Yeah, in our heads!
So now let's try to start piecing this all together. Since we know that m is equal to -1 over 2, and m is equal to the opposite of a over b, we could substitute and say 1 equals a and 2 equals b, and negative means opposite, so when we have ax plus by equals c, we can now have 1x plus 2y equals c. Remember what we said about arbitrary constants? We now know that for this line, 1 and 2 will always be the same no matter what ordered pair we choose of x and y to plug in as our variables. But we're not done yet. We still need to find out what c is.
C!
Dude, it's backwards.
C!
Now that we know 1x plus 2y equals c, all we have to do is choose one of the ordered pairs, which remember an ordered pair is made of an x-coordinate and a y-coordinate, and substitute them into our equation to find c. What's really cool is if you've done a good job so far, it doesn't matter which points you use. When you plug in the coordinates, you will get the same answer for c. Now that we know that c is 4, the equation of the line in standard form would be x plus 2y equals 4. And from here, slope-intercept is a piece of cake.
Cake, but I like pie.
So the name of our line in standard form is x plus 2y equals 4. Now remember, m is the opposite of a over b, and b is c over b. We can identify from standard form that a is equal to 1, b is equal to 2, and c is equal to 4. Well, 1 over 2 opposite would be -1/2, and 4 over 2, or 4 divided by 2, would be 2. So the name of the equation of this line is y equals -1/2 x plus 2. So the equation of the line, or the name of the line, that goes through the points -2, 3, and 6, -1 is, in point slope form, it's y minus 3 equals -1/2 times the quantity of x plus 2 minus -2, or y minus -1 equals -1/2 times the quantity x minus 6. In standard form, x plus 2y equals 4. In slope-intercept form, y is equal to -1/2 x plus 2. All 4 of these linear equations name the same line.
Say what? All that for one line? You crazy, Miss Coke. It can't be that easy.
Yes, it can. By the way, there's something I need to tell you about standard form. If the slope is negative, then you use ax plus by equals c. If the slope is positive, then you use ax minus by equals c. Let's do another example, and I hope you'll see what I'm talking about. So this time, let's try writing the equation of the line that goes through the point -2, 5 and has a slope of 3 over 4. Just watch how quick and easy it is to write the linear equation in all 3 forms, when you know all the neat tricks.
Yeah, let's do it. One more time.
Okay, we've got the point -2, 5 and slope 3 over 4. The easiest form to start with is point slope form, because point slope form is really just plug and chug. You have a -2 for x, in it goes. You have a positive 5 for y, in it goes. We always use the opposites, and then the 3 over 4 goes in for our slope. Boom, done. The next form I love is standard form. Remember that slope is the opposite of a over b? Well, that means 3 goes in for a, 4 goes in for b, and since we have a positive slope, we put a negative in between the two. Now we just need to find c. That's easy. Just take the coordinates of the point you were given, plug them in for x and y, do a little arithmetic, and what do you know? Bada bing, bada boom. We got our answer. See how easy this is?
Bada bing, bada boom.
Okay, now that we have the equation of the line in standard form, putting it in slope-intercept form is beyond easy. Remember we said that slope is equal to the opposite of a over b. A is 3, b is 4, the opposite is positive. So, y is equal to 3/4 over x plus, remember we said the y-intercept is equal to big C over big B? That would be negative 26 over negative 4. Now, we just need to clean things up a little bit. Remember, negative over negative is a positive, and we can reduce here our 26 over 4 to 13 over 2. So, 3x minus 4y equals negative 26 in standard form is y equals negative 3/4 x plus 13 halves in slope-intercept form. Well, that's the end of our lesson for today. I've enjoyed having you join me in my Crystal Math Lab, and I really hope you'll come back again someday. What do you say, Pi? Shall we invite them back?
Yeah!